Hello, my name is Jason Lotay, and I am Professor in the Geometry Group at the University of Oxford. And I'm going to tell you about deformed G2 instantons. And in particular, I'm going to focus on my joint work with Gonzalo Oliveira. So let me give you a quick overview of what I'm going to talk about. The first thing I want to answer is, what are deformed G2 instantons? And as you see, they are special connections which can exist on 7-dimensional manifolds. And they naturally arise as mirrors, in some sense. And from this perspective, one can hope to build enumerative invariants, at least in principle, for 7-dimensional manifolds, at least with some additional structure associated with the group G2. And the other nice feature that I'll explain is that deformed G2 instantons are critical points of a certain functional of Chern-Simons. Once we have this background, I'm going to discuss some results that we have for deformed G2 instantons. I'll explain the construction of the first non-trivial examples of these special connections, and then I'll describe some of their properties. In particular, I'll show how these examples enable us to detect different G2 structures on our ambient 7-dimensional manifold. And that will include the special classes of so-called nearly parallel and isometric G2 structures, which I will define. Then I will describe how these examples fit in to the deformation theory of deformed G2 instantons. That is, I'll describe how they're related to obstructions in the theory and to the topology of the moduli space. This is important from the perspective of enumerative invariants. And finally, I will discuss how these examples fit in with the variational perspective given by the Chern-Simons type functional. And at the end of all this, I'll give some open problems that I think are worth studying.